Hello, this is the third video for lesson 3, and we're going to talk about geometric dimensioning and tolerancing. There are 3 objectives for your lesson 3 objectives that deal with GD&T. That's 7, 8, and 9. 7 is differentiate between the various geometric symbols. These are the ones that are right here on this page. 2, draw the basic feature control frame, and we're going to talk about the basic feature control frame a little bit here, and then relate datum surfaces to part degrees of freedom. Okay, so GD&T is a means of defining features on drawings to make sure that it's a language essentially through codes and symbols that allows you to very accurately and very faithfully define the geometry of parts and positional tolerances and other tolerances. So, okay, so here are the things that these are the 5 basic types of tolerances that you can do with GD&T. Form, profile, orientation, location, and runout. Here's basically how they're used. And then with the characteristics. So for form, there is a straightness. There's also flatness, which has this parallelogram symbol, and circularity, which is roundness, and then cylindricity. That's a hard word to say. Those are all types of tolerances that deal with form. And then there's 2 tolerances that deal with profile. That's profile of a line and profile of a surface. And then orientation, angularity, perpendicularity, and parallelism. And then for location, like for holes, you can have position, and then you can also have concentricity. We kind of wrote concentricity out. GD&T kind of wrote concentricity out. There's nothing you can do with concentricity that you can't do with a position tolerance. So this is one of the symbols, concentricity. That's going to be going away eventually. Symmetry, and then circular runout, and then total runout. Those are runout tolerance. Symmetry, again, is another thing that's kind of going away in GD&T. So those are your basic types of tolerances and the entire characteristic tolerances. And here's some other symbols that we were using. These are modifiers: maximum material condition, least material condition, projected tolerance zone. Those are just the basic modifiers that you'll see in a feature control frame. Okay, so applications of position tolerance. Below are geometric and tolerance and symbols are applied to drawing, understanding datum features. Okay, so this is why GD&T is so good. It allows you to define features and then locate features with respect to those features. Okay, so we see this datum A here. So a line with a box around it that's tied to a surface, that is called a datum. So what happens is the lower surface of this part is datum A. Okay, and then based on that, we use that to locate other features. Like for instance, A sets up the orientation here for this feature here, which is a 20 millimeter hole, and it has a run out to A and C. Okay, so we're using A for orientation, and then we're also using C to orientation, and then we're checking this whole run out with respect to that. Over here, we have a positional tolerance. Okay, this would be the basic feature control frame. We have a diametrical symbol. This is the tolerance of position. And then we have a diametrical symbol of 14 thousandths. This would be the actual tolerance. And then the modifier, and then to A and C. So what we're doing is we're saying that this hole has to be in its position of 0.14 with respect to A and C. So what we do is we line up the part on A and C, and then we can check the location of these holes. Here's a way to apply datum features. So in this particular case, A is this datum of the part. C can be this side here. And what you do with, in this case, okay, A is applied directly to the object line in the drawing. C, this datum here, is applied with a leader. And then B here is applied to this surface here by virtue of this extension line. So you can apply datums to a surface, you can apply it to an extension line, or you can apply it with a leader. In this case, what we have is the feature of size, which is this diameter, becomes datum A. Here we're showing datum D with this little reverse triangle is the hole. Okay, here's another way to say that the hole is datum D. And then here's yet another way to do that. Okay, so datum reference frame provides a framework for eliminating the translations, movements, and rotation of which the part is capable. What we're talking about here is when you're doing GD&T, you're defining a frame of reference using the datums for your part. So in this case, we have datum surface A is this lower surface right here. Datum B is this side surface, and datum C is this upper surface. Okay, so we can completely give the part a frame of reference by using these datums. Okay, so first of all, you see this feature control frame here. We have our tolerance. In this case, our tolerance is a positional tolerance. We have our, this is like the characteristic. The characteristic here is a positional tolerance. Here's the actual tolerance value, 0.02 millimeters. This one says that the tolerance is applies at the maximum material condition, okay? And then these three datums, A, B, and C. Okay, so A is the primary datum, it's listed first. B is the secondary datum, this surface right here. And then C is the tertiary datum. Now, how do we relate that to degrees of freedom? If we were to locate the part using GD&T terms, it would kind of look like this. The primary datum is a surface, right? And that primary datum, that surface, can be picked up by 3 points. 3 points to find a plane. Primary datum A is a plane. Okay, so we can restrain that part about datum A using these 3 points. So now that we have the part restrained by datum A, we only need 2 pins to pick up the second datum. Okay, so this part will sit on datum A and we'll push that up against this second datum. And then finally the tertiary datum only needs 1 point to locate it because it'll stop all translation. So essentially, by taking our part and putting them on these 6 pins, we've arrested all degrees of freedom for mounting that part. So this is the beauty of GD&T. It gives you a frame of reference upon which to define all of your geometry. And it's a faithful way of doing it because it defines the part better and it defines the part more true than you would just by assigning tolerances. There's another presentation. I think you should go through that other presentation as well. Again, this is just an introduction to GD&T, and we're limiting to those three objectives. Differentiate between the basic geometric symbols. I want you to study this slide right here. Draw a basic feature control frame. There's a really good cartoon in the other presentation that talks about feature control frames. Let me see if I can find it rather quickly. This would be the other presentation in your And this tells you how to define a feature for control frame. This is the geometric characteristic. This is the shape of the tolerance zone. This here is the geometric tolerance. The modifiers are optional and only needed if required. Same with the projection modifier. And then these over here are the datum references. So this slide here tells you very concisely how to build and what the features are of a feature control frame. And the feature control frame in GD&T is what actually contains the tolerances. Okay, so that's the end of this slide, this movie. Good luck.